Question 4. In the last two paragraphs of the passage, the focus shifts from. To answer a question which asks about shift in focus, we have to be familiar with the passage. We need to read the entire passage. So I'm going to read the passage and map it. I start from line 10 because the first 9 lines are just talking about this spacecraft which went into to orbit Saturn and found what was happening around the atmosphere of Saturn. The paper shows the innermost D-ring of the gas giant is hurling dust grains coated in its chemical cocktail into the planet's upper atmosphere at an extraordinary rate as it spins. Over long timescales, the researchers say this infalling material may change the carbon and oxygen content of the atmosphere of Saturn, of course. I'll put that down. Innermost D-ring hurling chemicals into Saturn's atmosphere could change Saturn's atmosphere. Next, this is a new element of how our solar system works. So it seems to be telling us something about the way our solar system works. Says so and so. Two things surprised me. One is the chemical complexity of what was coming out of the rings. We thought it would be almost entirely water-based on what we saw in the past. Second thing is the sheer quantity, a lot more than we originally expected. The quality and quantity of the materials the rings are putting into the atmosphere surprised me. So let's put that down. I mean, it's all together just very little. That is, it's a new feature of the working of the solar system, and that the quality and the quantity of material that is being hurled out is very, very surprising for these researchers, what they found. Cravens is a member of Cassini's ion and neutral mass spectrometer. During Cassini's grand finale plunge into Saturn's innermost ring and upper atmosphere in 2017, the mass spectrometer aboard the probe sampled chemicals at altitudes between Saturn's rings and its atmosphere. So as it fell, it sort of read the compositions of whatever was there. Let's put that down. Spectrometer took samples at altitudes between Saturn's rings and atmosphere. And then, more than simply water, what did they find? They found rings to be composed of water, methane, ammonia, so a host of gases. That's what they found. We continue. What the paper is describing is the environment in the gap between the inner ring and upper atmosphere. The gap between, because it falls, D ring is the innermost ring and it is falling into the atmosphere because of gravity. And some of the things found were expected, such as water, and then what was a surprise was the mass spectrometer saw methane and then some of the other gases. Again, already mentioned, but repeating. So I'm not putting that down. What I'm going to put down is from the next paragraph. Also, it saw some carbon dioxide, which was unexpected. A further new finding showed large amounts of the chemical brew from Saturn's D-ring is flung into the planet's upper atmosphere by the ring spinning faster than the planet's atmosphere itself. So you're finding a reason. The ring spins faster than the atmosphere of the planet, and this causes the material to be spun out. So let's put that down. Hence, large quantity of material from D is flung. We saw it was happening even though it's not fully understood. What we saw is this material, including some benzene, was altering the upper atmosphere of Saturn in the equatorial region. So if I put that down, that is not able to properly understand, but we see that some alterations are happening to the atmosphere of Saturn in the equatorial region. Craven said the findings could cast new light on mechanisms underpinning our solar system as well as other solar systems and exoplanets and prompt a host of new questions. So, right, this is going to probably, it could explain the mechanisms that form our solar system as well as the other solar systems and exoplanets in the universe. This could help us understand how does a planet get rings, what's the life of a ring, what's replenishing the rings. So it could answer many of these questions. Let's put that down. Material is altering Saturn's upper atmosphere. Findings might help explain working of solar system, origin of rings, etc. So these are the range of questions it could be giving an answer to. How did the composition get in their first place? Is it left over from the formation of our solar system? So very exciting. All these answers could be found. According to Cravens, the higher than expected rate of material being expelled from Saturn's D-ring into the planet's upper atmosphere or ionosphere suggests that, now these are the little things it's important to notice how suddenly they've slipped in. The planet's upper atmosphere, there's a name for it, ionosphere, and Actually, there is a question based on this. What can you infer? The inference is from another part, and here they've slipped this in. So it's important that you note all this. So the material being expelled into the ionosphere suggests that the lifespan of the ring may be briefer than previously estimated. Okay, so material expelled is very high. That means lifespan of the ring might be brief. And we go into the last part, which is where we need to find the shift in focus. Because of this data, we now have shortened the lifetime of inner rings because of the quantity of material being removed. We know that it's bumping material out of the rings at least 10 times faster than we thought. If it's not being replenished, the rings aren't going to last. You've got a hole in your bucket. Jupiter probably had a ring that evolved into the current wispy ring, and it could be for similar reasons. Rings do come and go. At some point, they gradually drain away unless somehow they're getting new material. If I were to put that down, this data has led to the shortening of the lifespan of inner rings. That's the summary of that. Now, the last two paragraphs. Craven's main work involved interpreting the data with a focus on how materials from the rings are altering Saturn's atmosphere. So far, they were talking about what is the composition of the rings, what's happening to the rings, and what this could lead to. That means that the rings could be disappearing and forming, and this could be extrapolated to other planets too. Now, what are they talking about? The last two paragraphs. The rings are altering Saturn's ionosphere, Craven said, and his colleagues report the influx of chemicals from the rings changed Saturn's equatorial ionospheric chemistry by converting the hydrogen ions and triatomic hydrogen. So there's a change. My interest was in the ionosphere, the charged particle environment, and that's what I focused on. This gunk coming in chews up a lot of the ionosphere, affects its composition, and causes observable effects. That's what we are trying to understand. Put that down. Interpreting data, he starts focusing on how Saturn's atmosphere is changing. Observable effects are there, trying to understand them. Now, if I go to my questions, A, B, C, D, which one correlates with that? The composition of material in the D ring of Saturn, which is true. To the rate of dissipation of the material, no. That was in the previous paragraph, so no. That's not mentioned in the last two paragraphs. The composition of material present in the D ring of Saturn, 2. The speed of revolution of the ring, no. The composition and speed of dissipation of the D ring of Saturn, to its impact on the ionosphere, looks good, as long as you can read D and check that out. The rate at which D ring of Saturn is throwing material into the ionosphere of Saturn to the ring of Jupiter, no, that was not the shift. So C is the answer.